Thank you so much for having me. I will be presenting 20 minutes here today about what do you need to know about developer experience in 2025, and I'm assuming I'm in front of an audience full of platform engineers. So think about this: what do I need to know as a platform engineering team or a member about developer experience? I think that this topic is really important. I've been a big advocate of this, and because, different things, as Casper mentioned, let's go through this and let's see how well does this go. I have a couple of live demos. They will fail for sure, so let's give it a try. So as Casper mentioned, in 2021, I started writing this book, which is all about platform engineering, mostly on top of Kubernetes. How do you use Kubernetes to build platforms for organizations? This is all about managing clusters, creating new clusters, creating cloud resources, creating production-grade containers, doing GitOps, security and observability. That's kind of what platform engineers usually do. They use tools like Terraform, Pulumi, or even Crossplane that is covered there in the book for managing and creating cloud resources on top of different cloud providers or even on-prems. But since 2021 to now, I've seen a huge progress in the industry, in the communities, on how do we create APIs to abstract away all the complexity that all these tools represents for other teams that they don't care about Kubernetes or anything like that. Most of the time, we think about development teams, but also operation teams and other business teams that might be interested in consuming things from the platforms that we create. By participating in in the Cloud Native community, by writing a book that basically touches on 20 different projects, I made a lot of friends. And I wanted to call out one specifically, which is Thomas Vitale, who also lives here in Aarhus, who basically did a similar presentation to this one that I'm doing today in 2022 in KubeCon Europe. Right? You can check that out because I think that, again, if you see this session, you will see a lot of familiarity on the topics that I'm covering. Since 2022, we started discussing about how we need to think about developers when we are building platforms. And I think that if we want to build platforms for developers, we need to actually understand what they care about. So Thomas wrote a book that is very developer-centric for a very specific developer community, which is the Java community. And I don't know if you can read it there, but it says basically Spring Boot and Kubernetes. So he wrote this book thinking about what do I need to know as a developer to target Kubernetes as the platform where my applications will run? Which tools do I need? And which frameworks can go with the same idea that bundling everything as a container, scaling up horizontally, building stateless applications, and how do we deal with state? The more that you build cloud-native applications and distributed applications, the more important it is for developers to have the right infrastructure to test their applications and to validate that whatever changes they are making actually will work, right? And another thing that we noticed with Thomas by having a lot of conversations with a lot of developers is that top 3 frustration that they have is not being able to understand what's happening with their applications in production. If something fails and they cannot understand what's going on, it's very difficult to go and quickly fix the problem. So what we are doing here is basically looking into what platform engineers care, what developers care about, and how can we actually build platforms that solve some of these friction points. And that's why in 2024, around November, we decided to start writing another book that is titled Developer Experience on Kubernetes. And this book is pretty much trying to fill that gap because we feel that we do not talk about these topics enough in these communities, and I think that we can do much better. Because when you look at the tools that are available in the Cloud Native community, I think that there are still a lot of work to be done in that space, and that work needs to be done by the community, so we just need to talk about it. So the book is divided into 3 parts. This is not super important, but I will be talking about a little bit about the first part, the inner development loop, which are all the things that developers do quite a lot every day. And the second part is a little bit about the Cloud Native runtime, and I think that involves much more the platform engineering teams, what kind of services we can add to our Cloud Native runtimes. Let's say we are using Kubernetes as our runtime. What else can we add on top of that in order to make developers more productive? And the last part is about working out together so we can create tools in conjunction so we can help each other and the organization to deliver more value. So in order to start writing a book, you actually need to identify, again, as I mentioned before, a gap. And also we identified some patterns. And it is super clear that platform engineering and developer experience are not 2 separate problems. It's just the same problem, just looking at from different sides. The developer side or the platform engineering side, the cloud native side, or the very programming language specific ecosystem that they are trying to work together. So for platform engineers, I think that this is key, so I will read it super slowly. The current developer experience has a direct impact on how successful your platform initiatives will be, right? And basically what I'm trying to say here is that if you do not understand what your developers are doing today, any platform initiative that you start and try to push on top of them, it will be hard to make that successful because you are not understanding how you are changing the way that they are working. Because at the end of the day, developers know that platform initiatives will affect their developer experience in some way or another, right? It doesn't really matter what you're trying to do like in that initiative, but they know that if they need to learn new tools, new ways of doing things, they will stop doing what they are supposed to be doing, which is building value for their companies. So again, in the book, we take a very pragmatic approach. We divide kind of like the software development cycle into two big phases, the inner loop and the outer loop. And what we do is we recognize friction points in these tasks that developers perform and the involvement of the platform engineering team on the outer loop as well, right? So in order to do that, we try to, again, like identify places where things go wrong and then try to propose patterns to solve these challenges. We usually, when we talk to platform engineers, we like to start for the low-hanging fruit, like the thing that platform engineers can actually help today to sort out for development teams. And that's usually setting up a development environment, which can mean completely different things for different organizations. But in this case, I wanted to go over this first pattern that we cover in the book that it's called the development environment activation pattern. It's pretty simple, basic stuff. You have a development environment definition, which is a file that says, in order to do development in this project, I need all these tools to be installed. And I have all these requirements for a developer to start working on it. You have that into a repository of the project, and then when the developer clones the repository, in order to start working, they use some sort of tool to activate that development environment so they know for sure that they have the right tools in the right versions to start doing the work. Super simple stuff. The problem with patterns is that these are high-level patterns, then you need to look at the tools that implement these patterns. Because if you don't have the tools, then you will need to build a tool yourself. Probably the platform team will need your help there. So we look into two different approaches, the approach with containers and the approach without containers. Coming from the cloud native community, I was a very big fan of saying, oh, we can use containers to do that, let's use that. And we look into dev containers, which is a specification that was created by Microsoft to define what the development environment is. But as the name says, basically you take that definition, create a container, and then you ask developers to work inside that container with all the tools that were already pre-configured for them. But working inside containers, after trying this out for like the last year, has a lot of limitations, as we know. Like when you work with containers, you like on purpose put a lot of limitations just to make sure that your applications are isolated and all these things. When you're pushing developers to work in these environments, depending on what they are doing, you will need to figure out like all the workarounds just to get that stuff done. And that's why we started looking into different communities that are not so close to the cloud native community. And that's the Nix community. And I would love to know who knows Nix. So we have one fan here. Oh, there you go. This is like, just to be super clear, this is not super common. I've seen around like 30% of the audience raising their hands. And usually it's 5%, and usually it's like the fun boys, like very, very fun. Like if you're not like a hardcore Nix person, you're out of the picture, right? So, well, Nix, for the ones that don't know about the tool, is basically a package manager that has been built to be reliable, reproducible, and declarative. Unfortunately, for me at least, as a developer and like platform guy, when I look into Nix, I see something that is called the Nix lang, which basically allows you to define your packages and dependencies and all these things. And for me, that's a little bit way too low level for the things that I'm used to do, which basically means if I want to use Nix, I need to spend and invest a lot of time learning how it works. And that's why, like in this community, there have been other tools that basically are building more specific experiences. In this case, DevBox, or another tool that is called Flux, that basically is designed to create portable, isolated development environments, no Docker containers, and no super like low-level Nix knowledge is required to use these tools, right? Just to recap, the problem that we are trying to solve here is we have a wiki page that says, I need these tools in order to start working on this project. Or I have a GitHub README, it can be the same. But in order to work on these projects, I need to make sure that I have these versions. Because if I do not have these versions of these tools, then things can behave differently across different team members on the same team. So what I wanted to show you pretty much is how DevBox works with a very simple example. So I have like here I have a simple cloud native application that you can run in your clusters if you want to. It has 3 different services: the pizza store, the pizza delivery, and the pizza kitchen service. Very simple stuff, and it has these requirements: Java 25, Maven, kubectl, and the Dapper CLI. So what I will do here is I will show you, right? So if I do Java version, this is my path, right? Like this is what I have installed in my path. I have version 21, but I need version 25. I have kubectl here, kubectl version. I have 133.2, but I need 133.3, right? Like, so it's very similar. I don't know what's the difference between those 2 patch versions, but if there is one, I'm pretty sure that I will hit it with my team. So we need to be super careful. And the same with Dapper version, right? So I have 115, I need 116, so that's different. So what you can do with DevBox is to basically define which packages and versions do you need from the Nix package repository, which has like hundreds of thousands of packages. And then just define a simple JSON file that defines exactly that. Like, okay, I need, Java 25, that's Java 25. I need this version of the Dapper CLI and this version of kubectl to work on my project, right? This is like super declarative, very easy to understand, very easy to version in a Git repository where your project is, basically. So now what you can do is you can do DevBox shell to activate the shell with all these tools already pre-installed. You can see it's pretty fast as soon as you pre-compile this before. And now I'm in this shell where if I do Java version, I have the right version to work on my project there. Same with kubectl. By just doing this, we are just solving the drift of versions across different computers, across different operating systems in the entire development team, so this can help a lot. Just enforcing this is quite important. But more importantly is what you can do with this if you're using other tools that your developers are probably using, like code editors or IDEs. So if we go to the pizza store service, in this case, this is a specific service that I want to open with Visual Studio Code in this case, you will see that I don't need to do anything as a developer to have the right versions for me to work inside this project, right? So I have the Visual Studio Code here. I don't know if you can see there, but basically there it says DevBox. That basically means that that's a DevBox-enabled terminal. And what I wanted to do here is I just want to copy a command from here, which basically starts the application using one of the binaries that I've already installed as well using DevBox. And the only thing that I want to show you here, like the application is not important, is that the binary that I use, it's coming from the Nix store. Again, this is a package that I'm managing using this tool. And then I just want to check that the Java version that I'm using to start the application is Java 25 here. I don't know if you can see it there in the back, but it is Java 25. Again, I didn't need to do anything, just open my editor and start working with the project because like all the tools are being managed, in this case, by DevBox. Again, you should check dev containers as well. It's a good solution. We found some issues, but like it's a good solution so far. So now the second part of the presentation, it's about a little bit more closer to what we do as platform engineers. As platform engineers, we define how our environments work. And I'm not talking about development environments. I'm talking about the environments where we are going to run our applications in front of our customers. But still, it's important to define the contracts between what developers do and what do we do as like to define kind of like what these runtimes are going to be. Most of the times when we talk about like contracts in the cloud native space, we talk about containers, right? As soon as a development team can create a container, we can run a container in these production environments. And that's quite good, but that's still for me as a developer, as a platform engineer, I can see that that's very low level because whatever you do inside that container might be completely different of what you do in other containers. So what else can we provide to developers to simplify their tasks when building distributed applications? That's the questions that we are trying to solve here. And spoiler alert, if you have seen any of my presentations, in the same way that we created platform APIs to abstract complexity from the consumers of the platforms, we can actually provide API to developers so they can have a simplified job to create their cloud native and distributed applications. What these APIs are going to do is they are going to hide away complexity that is related to the environment, the cloud native runtime where we're running. The problem, again, when you go into these discussions about, okay, how do we enable developers, is all about understanding the gap between these two big roles, developers and platform engineers. Platform engineers are great of dealing with infra and Kubernetes and extending Kubernetes with controllers and creating new CRDs to expose new APIs. All these things can be done in any language. The Kubernetes community have done a lot of things in Go, but nowadays you can pretty much do it in any language that you want. But when you go to developer tooling, it's completely different. It's very specific to the language that you're using, the frameworks that you're using, and the ecosystems where you're embedded to. So even having kind of like a very specific library for like the Java ecosystem, the .NET ecosystem, need to follow certain rules that are not super clear, and you need to go and understand that community in order to actually integrate there pretty well. And that's why I wanted to talk a little bit about Dapper here, the project that I'm working on, because we kind of like we do like a lot of work across Kubernetes and the developer land, because Dapper was created to decouple application infrastructure from applications with APIs. So how it works, and again, here like this is not a Dapper presentation, but it's more about like showing how Dapper implements these two sides and the advantages of doing so. So Dapper works like that. You install Dapper into a Kubernetes cluster, and what Dapper does is for every application that you deploy, that you mark that wants to use the Dapper services, Dapper will inject a sidecar that will expose a set of APIs for the application to use. What these APIs are doing is they are enabling you to access secret stores, message brokers. Nowadays, we can access LLMs in a way that the application only needs to understand what the API is and nothing else, right? But on the developer side, we also have language-specific SDKs that integrate, with the specific ecosystem that we are talking about. We have a Java SDK, a Go SDK, a .NET SDK, a Rust SDK, a Python SDK. The important thing about these SDKs is that developers usually care about calling APIs, right? Like let's say that we have a remote API to access an LLM, right? Like let's say we have OpenAI somewhere that we need to access. The developer cares more about sending a prompt and getting the results than the code that it's being used to just call that LLM, or if it has retry mechanisms or circuit breakers, or if it's observable or not, right? The fact that we provide SDKs is basically to abstract and implement all these client-side concerns like resiliency, observability, and security on the client side. So if something fails calling OpenAI, we deal with that in the SDK, and we don't surface all the low-level errors to the user. So they can, again, focus on sending prompts and getting back the replies. When you build these kind of projects, you need to kind of like rely on specs that are out there. In the cloud native space, we have the OpenTelemetry spec, and this is extremely important when you build tools that are across like clusters and SDKs and CLIs, because you want to make all these tools observable in the same way. So if you are interested in that topic, there is a blog post from -0 where they basically describe the advantages of having OpenTelemetry all across the board. Super important for platform engineers, and when thinking about developer experience, relying on these specs is extremely important. But this raised the question, right? Now I'm talking about the tool that runs inside the cluster, provides APIs to access cloud resources and infrastructure or cloud services like OpenAI. What does that mean for the inner loop of developers? How do they work with all these things if you ended up requiring a Kubernetes cluster, tokens to access OpenAI, and all that stuff? And the answer is, like, actually, you can build these experiences with tools that are specific for the ecosystem. Every kind of like programming language ecosystem will have a bunch of tools that can help you to recreate some and wire up all the components that are needed for local development. And we have been doing that, at least for the Java community and the .NET community, with test containers and microcs. So test containers is a project that allows you to start, containers locally for developers to use. And microcs is a tool, it's a CNCF tool that basically allows you to host mocks for your services. And it's very efficient on doing that for the local development experience without like crazy requirements or having a cluster even ready. So I wanted to close this presentation by show you that, like the application that I've started here, the pizza store. As I mentioned before, I'm running here only the front end, right? So, and I don't know if you can see that. I will try to zoom in here. But you see that there are like 2 services down that I'm not running here because I just started one of those, right? And the pizza store service basically allows you to place, pizza orders here. So I can place an order, and I should be able to see that like the store is sending events to the kitchen, to the delivery service, so the order gets delivered, right? And this is pretty much what you're seeing here, like a bunch of events that are coming back and forth between services in order to actually process the order. Remember, I'm not running the other services. That basically means that I'm mocking something, right? So I'm mocking these other services. And the same thing can be done with like OpenAI in this case. So I have like a way to create an order from an OpenAI prompt. So I send a prompt, and then I get back kind of like an order correctly formatted for the pizza store to process. So I can do here something like, hello, I want the pepperoni pizza and a beer. and I can send that to OpenAI. If I'm running in production, I will talk to like a real LLM, but if I'm running here for local development purposes, I'm just calling probably a mock that understand how to get this request and how to reply something that is useful back to the application. So you can see here, I have an extra step that is basically doing those things, and kind of things work. Again, just to reflect a little bit on this, to close with the last slide, I have one more second, which is basically reflecting a little bit on the things that I've covered in this presentation. Developer experience and platform engineering are not two separate problems. If we are trying to do a good platform, we need to think about developer experience and how are we affecting developers. And with all the rise of agentic systems, LLMs, and all the craziness that is happening on AI, more and more developers want to use these features, but as platform engineering teams, we need to start building the process on how do we curate the tools that are ready for production. That's extremely important. And from my side, writing a book about these topics, we are keeping an eye on the new tooling that is popping up, the new patterns and the new friction points that are popping up, like downloading gigs of more large models to run locally, which is kind of like a pain, but it's one of the solutions that we can use. With that, thank you so much. Make friends, because this is the place to make friends in the community. And if you're interested in the topic or the book, please reach out, because we are always eager to collaborate with the community. So thank you so much.